this time we're going to start covering Science Section 1, the foundations of astronomy. For those of you curious as to why I'm switching over to science, starting tomorrow, Dulles will be working on science, and so I figured I'd make this video ahead of time. And so I'll start putting out science videos, so I will eventually get back to social science, of course, and art fundamentals. But until then, join us on our trip through science. So obviously, this is all about astronomy. This whole section is about the history of astronomy, and today we're going to cover ancient astronomy, the astronomy of the Greeks, and then the Copernican revolution. Scientific observation has shaped our understanding of the universe over the course of thousands of years, and this section is going to cover the major events in the history of astronomy and then talk about how telescopes work and their role in modern astronomy. So a few years ago with lasers, they had a lot of that similar stuff, and when I first saw in this section, I was panicking because I think that was the hardest part of that science that year, was the way that lenses work. But it's not too bad this year. So let's start with ancient astronomy. We don't have a whole lot of knowledge about the first people to study the behavior of stars and planets because they had no written records. But we do have a lot of evidence that almost every ancient culture both observed and reviewed the patterns in astronomical phenomena. And one of our major examples is Stonehenge, which is a massive stone structure built on the Salisbury Plain in England, and it was constructed in stages between 3100 and 1600 BCE. We have particular pathways and stones aligning with pretty significant astronomical events, which suggested that these structures were used as calendars. And the image that they have is about the heel stone, and this heel stone of Stonehenge aligns with the sun on the morning of the summer solstice. So let's take a look at that. Oops. Let me see where I put that. There it is. All right, so here is Stonehenge. Obviously, you've seen what Stonehenge looks like. I don't need to stay too long on this, but here is the heel stone aligning with the solstice. I don't know if this is the real one or a fake one, but this is kind of the idea of what it looks like. It looks like it's actually probably the fake one, but this is the idea, is that the heel stone is supposed to align with the sun on the summer solstice. Where is it? There it is. All right. Next, we have the Temple of Isis, located in Dera, Egypt. And this temple aligns with the point on the horizon in which Sirius appears to rise. I cannot find an image of that, but the appearance of Sirius coincided with the flooding of the Nile, which played a pretty massive role in Egyptian agriculture and mythology. And the way that the flooding of the Nile worked so predictably was that the mountains in Ethiopia, the ice caps would flood at the same time each year, leading to the flooding of the Nile further down it, or further north of it, right? So let's take a look at the Temple of Isis here. As you can see, so I'm guessing maybe either the top or maybe through the pathway would align with the appearance of Sirius. Okay. Lastly, we have the Sun Dagger, which is a interesting rock sculpture carved by the Native Americans in the Chaco Canyon of New Mexico, which exhibits alignment with the sun on the summer solstice. But as I kind of look through images of it, it's not just that. So here is an image of what the sun dagger does. So you have this kind of like circular kind of pattern here, right? And then the sun comes through this particular they put a bunch of stones up, and so the light from the sun comes through there in particular ways during particular times of the year. So the summer sun, spring and fall sun, and the winter sun. And then on the spring equinox, you can see it right here. And the summer solstice is right in the middle. The fall equinox is the same place as the spring. And then the winter solstice, you actually see two lines, right? So I think that's really cool. Okay. So observations of astronomical patterns of phenomenon were really important for just practical purposes at the time. Probably the most important part is that it allowed to create calendars for farming, mostly to plan harvest crops, right? But then also we of course see certain stars as navigational aids, especially Polaris, the North Star. So we see all in all, early astronomy plays a pretty important role in the survival and scientific advancement of the ancient societies. But the first society we really have a lot of records of astronomy are the ancient Greeks. And so the Greek philosophers really sought to explain variations in the brightness of the planets and their wandering motion in the sky. And apparently that's where the term planets comes from, because the Greek word planetes means wanderer. need to make sure that's right. I'll come back in here and check that one. Means wanderer. So actually the planets are the wanderers of the sky. And the first, they talk about a lot of guys here, but the first one is Thales of Miletus. He was among the first to suggest that a natural phenomenon could be explained and understood by humans. So he doesn't really do anything astronomical. He is just one of the first to kind of say, like, actually the things we see can be explained and can be understood by us around 600 BCE. And that's very, very early in the ancient Greek times. The Greeks that we tend to think of are around the 4th and 3rd century BCE. So yeah, that's a much earlier. That's very ancient. And usually the Greeks that after this are kind of called the classical Greeks, but whatever. I'm not gonna pick at that too much. Pythagoras also noticed mathematical patterns in nature. He himself was a Greek mathematician and philosopher. You probably know him from the Pythagorean theorem. And he proposed that patterns could be extended to the behavior of stars and planets. So the mathematical patterns on Earth could be extended to the stars. And then we get into our first kind of main guy here, Plato. Plato had some very interesting theories about Earth. He believed that we had this world of forms and the world of ideas, I believe is the other one, where basically we live in this kind of this world that's a representation of the real world, and the real world is made up of perfect shapes, platonic solids. If you've ever seen the allegory of the cave, this is what he's explaining in that. Tetrahedrons and cubes being two of the platonic solids, but actually, let's see if I have it here. We have tetrahedrons, we have cubes, we have octahedrons, icosahedrons, and dodecahedrons is kind of the major platonic solids. And of course, the most perfect of those, though, is going to be a sphere, right? Which makes sense, right? You carrying that sphere idea, he proposed then that the heavenly bodies in the sky are encircling Earth in a series of concentric spheres. So it's almost like a Matryoshka doll, right? Where you have the smallest doll is Earth, and the next doll is the moon, and the next doll is Mars or the sun, or whatever the order would be for Plato, right? And then one of his students, Eudoxus of Cnidus, extends this idea of concentric spheres by actually kind of measuring it out. And he proposes that there are 27 concentric spheres rotating around the Earth at different rates, which I'm presuming those 27 align with the 27 major celestial bodies that the ancient Greeks could observe. And then we have Aristotle, who is another student of Plato's, but he was actually a lot of the times very much against Plato's ideas, where Plato saw believed that we had this kind of other world of forms and ideas. Aristotle believed that everything we observe with our senses is the real world, right? And you can't prove otherwise, right? But in terms of natural philosophy, I guess, he proposed a geocentric model of the universe, which put the Earth at the center of it. And he did this during the 4th century BCE. However, not all Greeks agreed with Aristotle's view here. We have Aristarchus in the 3rd century BCE. So this is the 200s. This is the 300s. He proposed that Earth and other planets revolved around the sun, which, as we know today, is more correct. But Aristotle's influence was too great, and so Aristarchus' view is not really accepted. And in fact, some 300 years later, Claudius Ptolemaeus, also known as Ptolemy, extends this idea around 150 CE. Sorry, extends Aristotle's idea of the geocentric universe by fitting it within the existing data they already had on planetary motion, so basically making the math work, essentially. And he described the sun, moon, and planets as moving on small circles within their geocentric orbit, which they called epicycles. And then these epicycles trace larger circular pathways around the Earth called deference. Let's take a look at that, actually, if we can. I think I have it here somewhere. Yeah, so basically the Earth is the center, and then all of the other planets are rotating, and the sun are rotating around the Earth, and the stars kind of have their own thing. And then some of the objects like Mercury and Venus and Mars and Jupiter and Saturn all are on epicycles, which means they spin they basically spin along their orbit. They're deferent, right? So the orbit itself is the deferent, is what they call those, right? And then these small movements are the epicycles. And so this model, the Ptolemaic model, is the basis for astronomical work for 14 centuries. So we're looking at about, the 1400s, 1500s that we see that start to be challenged, and we're actually going to see that challenged here in a second. Because it did describe observed positions and motions with pretty good accuracy, as they were known at the time, and his teachings became central to the teachings of the Roman Catholic Church with some modifications. Which, if you've read all of science yet, it's kind of wild to think about, like, this was the accepted model, and where we are now with, like, the things we're looking at throughout the entire galaxy is incredible. Lastly, for this section, we have the Copernican Revolution. So Nicholas Copernicus, this guy here, look at that hair, it's phenomenal. He was born in 1473. He is Polish, from Poland. He's obviously an astronomer. And he spent many years of his life, I should say most, but a lot of years of his life writing a book called On the Revolutions of the Celestial Spheres. And in this book, he proposed a heliocentric, a sun-centric, sun-centered model of the universe. This is poorly written. Let's say Earth is not central. So in the Copernican model, again, the Earth revolves around the sun, and the Earth is not central to the universe. Copernicus obviously waited a very long time to publish this theory, mostly because it was very controversial in that it challenged the central teachings of the Catholic Church. And as we're going to see, the Catholic Church and people's their response to astronomers is going to heavily influence early astronomy, or at least astronomy of this era, I should say. And so the Copernican model was very successful explaining the aspects of planetary motion that earlier models could not. One of the key things that he helped explain is retrograde motion. And retrograde motion is this idea that the planets in their orbit would actually look like they would go backwards, right? So instead of continuing this very steady pattern of orbits, they would actually go backwards a little bit and then continue. This, again, is known as retrograde motion. And the Copernican model explains this very well by, especially in the context of Mars, that Mars never actually moves backwards in its orbit, but because the planets move in uniform directions, but rather the Earth was moving faster than Mars. And so basically, their orbits kind of, if their orbits were going like this for a while, right, Earth was going faster at some point, so it looked like Mars was going backwards, right? All right, so Earth is faster moving, catches up to Mars, moves past it, and again, Mars appears to move backwards. And so Copernicus publishes his book in 1543, the year he dies. So sounds like he did that on purpose. It was not a complete set, or not a complete kind of work, but his heliocentric model becomes highly influential on later scientists, as we'll see, and kind of completely changes the way we view the world. And this is a revolution. It's a Copernican revolution, which again refers to his insight that the Earth is not the center of the universe. So in this video, we covered the Copernican revolution, about how we shifted away from a Earth-centric universe to a sun-centric universe. We covered the Greeks, who really kind of first came up with the ideas of a Earth-centric universe. And then we also talked about ancient astronomy with Stonehenge, the Temple of Isis, and the sun dagger. In the next video, we're going to cover Kepler and the scientists that come after him, the astronomers that come after him, I should say. But thank you guys so much for watching, and I will see you in the next one.